Today we're going to be looking at germ theory and the work of Louis Pasteur and Robert Koch. As a bit of a recap, there wasn't a lot of new ideas about the causes of disease in the 18th century. Ideas such as the theory of the four humours had been discarded, and people still believed in miasma, although this theory was also becoming less popular during this time. Scientists in the early 18th century developed this theory called spontaneous generation as an alternative to theories like the four humours. Improvement in the quality of glass lenses used in microscopes meant that scientists could see microbes present on decaying matter. However, most people believed that these microbes were the product of decay rather than the cause of it. They thought decay caused these microbes. In the 18th century, this was just one theory, and scientists were unable to prove that spontaneous generation was correct. And it took until the 19th century for scientists to make a solid link between the microbes and the disease. In 1860, the French Academy of Science challenged scientists to come up with evidence to either prove or disprove the theory of spontaneous generation. And by the middle of the 19th century, microscopes had become quite advanced. It was now possible to magnify substances to much higher levels and keep the image clear enough to see. Because of this, Louis Pasteur, a French scientist, was able to observe unwanted microbes in wine and vinegar, which turned both liquids bad. Pasteur published the results of his experiments in 1861, and he called his discovery germ theory. Pasteur proved that the idea of spontaneous generation was wrong because decay did not happen to sterilized matter that was left undisturbed. Instead, something in the air was causing decay. Pasteur also theorized that as germs were causing decay, they might also be causing disease in the human body. And he observed one particular type of microorganism killing off France's silkworm population, which seemed to prove his theory. However, he did not publish his germ theory of infections until 1878. To begin with, Pasteur's work had almost no impact on British ideas about the cause of illness and disease. He was not a doctor. He was a scientist, and his work focused on decay and spoiled food, not disease. And in Britain, the theory of spontaneous generation continued to be important until the 1870s. It was promoted by doctors such as Henry Bastien, who was one of the most powerful doctors in the country. Because he was so well respected, few people disagreed with him. However, some scientists did start to look for a link between the microbes and disease, and one of these was Joseph Lister, who read Pasteur's germ theory and linked it to the infection problem in his surgery patients. Another scientist who promoted the link between microbes and disease was John Tyndall. He discovered that there were small organic particles in the air. In January 1870, he gave a lecture linking his discovery with Pasteur's germ theory and Lister's work on wound infection. Tyndall theorized that dust particles carry the germs that cause disease. So Pasteur's work had limited impact in Britain because attitudes among doctors meant people refused to recognize the link between germs and disease, even though the link was correct. This was because, just to re-emphasize, he was a scientist and not a doctor, and people were not willing to believe him. If we have a quick look at this image here, we can see on the left these old ideas of spontaneous generation. This is the theory that rotting matter created microbes. And the new idea, germ theory, which eventually replaced spontaneous generation, was this idea that actually it was the microbes that were causing decay and were not created by rotting matter. Pasteur had been the first scientist to identify microbes and their role in decay. However, it was the German scientist Robert Koch who had successfully identified that different germs cause many common diseases. So if we have a look back at this image here, what Pasteur could see here under these new microscopes was this kind of image here, where it was easy to identify the blood and the microbes. What Pasteur couldn't identify, couldn't isolate which of these microbes were causing the disease within humans. And this is where Robert Koch came in. Robert Koch was successful in identifying the different types of bacteria that caused illness. And Koch was able to do this through a process of using dyes to highlight the different bacteria. And in 1882, he discovered the bacteria that caused tuberculosis. Koch continued to look for microbes causing different diseases. In 1883, he discovered cholera, and in 1884, he proved that it was spread in water supplies when he found it in the drinking water in India, where a cholera epidemic had broken out. This also provided proof for John Snow's theory, which we'll come to later on. Koch's research inspired other scientists, and over the next 2 decades, they went on to discover the microbes responsible for other diseases such as diphtheria, meningitis, the plague, tetanus, and various other infections. Koch received the Nobel Prize for Medicine in 1905. He is considered to be the founding father of bacteriology, and his methods are still used today for seeking out microbes. But is this progress? Could we say that this is progress? Progress in treatment and prevention using germ theory was slow. Once Pasteur and Koch and other scientists had found the specific disease causing microbes, cures and vaccines could be tested. Only after this did germ theory begin to have a direct impact on medical treatment. Even the British government rejected germ theory of disease at first, and it was only much later that the government accepted the ideas of Pasteur and Koch.